The morning fog clung to the North Sea coast like wet wool as Hauptmann Horst Gutz circled the strange aircraft sitting on the frozen tarmac. This wasn't supposed to be here. The twin-engine fighter wore British roundels, though someone had hastily painted crude German crosses over them. Its Bristol Beaufighter designation was still visible beneath the hurried paint job. The aircraft had landed 3 hours earlier, bellowing smoke from both engines, its Australian pilot barely conscious from blood loss. Gutz had seen dozens of captured Allied aircraft during his posting to Luftwaffe Erprobungsstelle Rechlin, the experimental testing center where Germany evaluated enemy equipment. Spitfires, Hurricanes, American Mustangs, all had been impressive in their own right, but this British machine, this ugly brute with its blunt nose and massive engines, had flown through a Norwegian winter storm with one engine failing and battle damage that should have killed any aircraft. The pilot had somehow coaxed it to an emergency landing rather than bailing out over the freezing North Sea. What Gutz didn't know, what none of the German technical officers standing in that cold March dawn could have predicted, was that this captured aircraft would fundamentally challenge everything the Luftwaffe believed about fighter design. Within weeks, test pilots would be filing reports that seemed almost treasonous in their praise. Within months, German engineers would be desperately trying to reverse engineer systems they'd dismissed as British over-engineering. And by war's end, captured Beaufighter pilots would admit in interrogations that flying British heavy fighters felt like glimpsing the future of aerial warfare. The story of how Germany's most experienced test pilots came to respect, fear, and ultimately envy the Bristol Beaufighter reveals a truth that German aviation never fully accepted. Sometimes brute force engineering, backed by practical British ingenuity, could produce something approaching perfection. This is that story. The aircraft that had crash-landed at Stavanger was a Bristol Beaufighter Mark VI, serial number VIF 427. It belonged to No. 248 Squadron of RAF Coastal Command, based in Scotland for anti-shipping strikes along the Norwegian coast. Flight Lieutenant James Harrington, its 24-year-old pilot, had been attacking a German convoy when flak had shredded his port engine and wounded his navigator, rather than ditch in the North Sea, where survival time in March waters measured in minutes. He'd nursed the crippled fighter toward what he thought was neutral Sweden. He'd miscalculated by 60 miles. German recovery crews found Harrington unconscious in the cockpit, his navigator dead from blood loss in the rear compartment. The Beaufighter itself was a treasure trove. Unlike aircraft that crashed and burned, this one had landed relatively intact. The engines were damaged but rebuildable. The weapons systems were complete. Most importantly, the radar installation in the nose remained functional. This was the airborne interception radar that allowed Beaufighters to hunt German submarines and shipping in complete darkness, technology the Luftwaffe desperately wanted to understand. Oberst Friedrich Müller, commanding officer of the testing facility at Rechlin, received the telegram at noon. Intact Beaufighter captured Stavanger, minimal structural damage, request immediate transport for evaluation. He read it twice, then reached for the telephone. Within 6 hours, a Junkers 52 transport was heading north with a team of technicians and every manual on British aircraft they possessed. The Bristol Beaufighter had earned its fearsome reputation the hard way. First flown in July 1939, it was designed as a heavy fighter and night intruder when the Air Ministry realized they needed something bigger than the single-engine fighters. Bristol Aircraft Limited took their Beaufort torpedo bomber, stripped out the bombardier position, crammed in 4 20mm cannon and 6 machine guns, and created what pilots immediately called Whispering Death for the distinctive muted roar of its Hercules engines. By 1943, Beaufighters were the scourge of German operations across multiple theaters. In North Africa, they shredded Rommel's supply convoys. Over the Mediterranean, they sank so many German ships that Axis sailors called the appearance of Beaufighters Black Friday. Along the Norwegian coast, they devastated German shipping with such regularity that convoy operations became near suicidal. And at night, over Germany itself, Beaufighter night fighters were shooting down German bombers with terrifying efficiency. German intelligence had compiled extensive files on the Beaufighter, but intelligence reports couldn't convey what it felt like to fly one. The numbers were impressive, but abstract. Top speed of 330 miles per hour. service ceiling of 26,000 feet, range of 1,500 miles with external tanks, armament that could sink a destroyer, but numbers on paper couldn't capture the experience of actually sitting in the cockpit, feeling the power of those two Bristol Hercules engines, experiencing the rock-solid stability that made it the perfect gun platform. Hauptmann Goetz arrived at Stavanger on March 26th. He was 31 years old, a veteran of the Battle of Britain with 14 confirmed victories, and one of the Luftwaffe's most experienced test pilots. His job was to evaluate captured Allied aircraft and report their strengths and weaknesses. He approached every assignment with clinical objectivity, finding flaws in even the most celebrated enemy designs. He walked around the Beaufighter with his engineering team taking notes. The aircraft was 50 feet long with a wingspan of 57 feet. It sat high off the ground on sturdy landing gear, giving it an almost predatory stance. The nose was blunt, almost ugly, housing the radar installation and 4 20mm Hispano cannon. 2 more cannon pods hung beneath the fuselage. 6 machine guns were mounted in the wings. The twin Bristol Hercules radial engines bulged from the wings, each producing 1,600 horsepower. "It looks like someone built a fighter out of spare bomber parts," observed Lieutenant Werner Schmidt, one of Goetz's engineering officers. "Everything about it is oversized." Goetz nodded but said nothing. He'd learned that British aircraft often looked crude compared to sleek German designs, yet performed superbly in combat. Underestimating British engineering had proven costly too many times. The technicians needed 2 weeks to repair the battle damage and make the aircraft airworthy. During that time, they cataloged every system, every design choice, every detail. What they found increasingly impressed them. The Beaufighter was built like a battleship. The main structural members were massive compared to German aircraft. The control cables were doubled throughout. The fuel tanks were self-sealing, lined with rubber that swelled when punctured to seal bullet holes. The electrical system had multiple redundancies. "British over-engineering," Schmidt commented, but his tone was less dismissive now. "They build everything twice as strong as necessary. Or perhaps they build things exactly as strong as combat requires," Goetz replied, "and we've been building ours too light." On April 9, 1943, the captured Beaufighter was declared ready for flight testing. Goetz would fly first with Schmidt in the navigator's position to monitor systems. A Messerschmitt 110 would chase as a photo aircraft. Ground crews had repainted the aircraft in German markings and added high-visibility panels so German flak batteries wouldn't shoot them down. At 6 in the morning, Goetz climbed into the cockpit. The first surprise was space. German fighters were cramped, designed for small men. The Beaufighter's cockpit was roomy, almost comfortable. The seat was adjustable. The instrument panel was logically laid out, easier to read than the cluttered panels in Messerschmitt fighters. The canopy provided excellent visibility in all directions. He studied the controls. Stick and rudder pedals were conventional. Throttle quadrant on the left held 2 throttle levers, propeller pitch controls, and mixture controls. The British used different procedures than the Luftwaffe, but the systems were straightforward. German engineers had prepared a translated checklist. Goetz worked through it methodically. Battery switches on, fuel selectors to main tanks, propellers to fine pitch. Throttles cracked open, magnetos to both. Booster pumps on. He pressed the starter for the port engine. The big Hercules coughed, belched smoke, then caught with a deep rumble that vibrated through the entire airframe. He brought the starboard engine to life. The noise was surprisingly muted for such powerful engines, nothing like the harsh roar of German radials. The British had somehow made 1,700 horsepower whisper. Goetz checked temperatures and pressures. Everything was normal. He waved away the wheel chocks and advanced the throttles. The Beaufighter rolled forward with surprising ease for such a large aircraft. The tail came up quickly as speed increased. At 80 miles per hour, he eased back on the stick, and the Beaufighter lifted off as smoothly as any aircraft he'd flown. The first impression was solidity. No vibration, no wobbling, just smooth, controlled flight. He retracted the landing gear and felt the aircraft accelerate. He climbed to 5,000 feet and began basic handling tests. The Beaufighter responded to controls like a much smaller aircraft. Light pressure on the stick produced immediate response. The rudder was powerful and effective. There was no tendency to drop a wing or yaw unexpectedly. He tried some shallow turns. The aircraft banked smoothly with no adverse effects. He tightened the turn, pulling more stick. The Beaufighter responded obediently, carving through the sky with precision. In a German twin-engine fighter like the Messerschmitt 110, tight turns felt sloppy and dangerous. The Beaufighter turned like it had been designed for it. Goetz keyed his radio. "Schmidt, how are the engines looking?" "All temperatures normal, Herr Hauptmann. Oil pressure steady. This is remarkable smooth power delivery." Goetz leveled out and checked airspeed. 290 miles per hour in level flight at 5,000 feet, using moderate power settings. He advanced the throttles to maximum continuous power and watched the airspeed climb. 310, 320, 330. The aircraft was rock steady. No buffeting, no control heaviness. He tried a dive. The Beaufighter accelerated smoothly, reaching 400 miles per hour with the engines still pulling strongly. German twin-engine fighters became difficult to control in high-speed dives. The Beaufighter tracked straight as a rail. For 2 hours, Goetz put the aircraft through every test he could devise. Stalls were gentle and predictable. Single-engine handling was excellent, far better than any German twin he'd flown. The aircraft could maintain altitude on one engine at normal weights. Aerobatics were smooth and controlled. Even deliberate mishandling produced no vicious tendencies. When he landed, Goetz sat in the cockpit for several minutes, organizing his thoughts. Then he climbed down and walked directly to the operations building, where his engineering team waited. "Gentlemen," he said, "we have a problem. That aircraft is better than anything we have in its class." The room went silent. Lieutenant Schmidt spoke carefully. "Herr Hauptmann, perhaps you should clarify what you mean by better." Goetz set his flight gear on a table and pulled out his notes. "The Beaufighter is stable in all flight regimes. It's faster than our Messerschmitt 110 at low altitude. It handles like a single-engine fighter despite weighing 7 tons. Single-engine performance is superior to any German twin. The cockpit visibility is excellent. The controls are beautifully harmonized. And we haven't even tested the weapons or radar yet." Over the following weeks, additional test pilots flew the captured Beaufighter. Each one filed reports that echoed Goetz's assessment. Major Hans Faber, who commanded night fighter operations, was particularly impressed after his flight on April 23rd. "This would be the perfect night fighter," he wrote in his report. "The stability allows precise flying on instruments. The radar installation is integrated properly, unlike our equipment, which feels like an afterthought. The armament concentration in the nose eliminates convergence problems. A pilot could track a bomber steadily and destroy it with a single burst." The weapons testing proved devastating. On April 30th, the Beaufighter was armed and sent against a target ship in the fjord. Goetz made one pass, firing a 2-second burst from the 420mm cannon. The target ship, an old fishing vessel, simply disintegrated. The concentration of firepower was beyond anything German fighters could produce. 4 cannon firing together create a stream of destruction, Goetz noted in his report. The recoil is noticeable but not uncontrollable. The gun platform stability means every round goes where you aim it. I observed my shells walking directly through the target with no dispersion. This is how cannon armament should be installed. The German engineers began detailed measurements and analysis. What they discovered was a masterclass in practical aircraft design. Every system showed evidence of operational experience informing the engineering. The wing structure used a unique torsion box design that was both lighter and stronger than German approaches. The undercarriage was over-engineered to handle rough field operations. The fuel system could transfer between tanks automatically, something German aircraft couldn't do. The hydraulic system had multiple backups. Even small details showed thoughtfulness. The pilot's seat had armor protection that actually covered vital areas, unlike German armor that was often poorly positioned. The canopy could be jettisoned explosively for emergency egress. Oberst Müller visited from Rechlin on May 7th to observe the testing personally. After his flight, he gathered the team for a frank discussion. "I need honest assessments, gentlemen. Not what you think the high command wants to hear, but the truth. How does this British aircraft compare to our fighters?" There was uncomfortable silence. Finally, Goetz spoke. "Herr Oberst, if we could build something like this, we should. It's superior to the Messerschmitt 110 in every measurable category. It's more stable than our Junkers 88 night fighter. It's better armed than anything we have. And based on combat records, it's more survivable than our fighters." Müller nodded slowly. The radar. The British are years ahead of us in airborne radar, admitted Major Faber. Their AI Mark IV system is integrated into the aircraft properly. Our Liechtenstein radar is crude by comparison. The British have solved problems we're still struggling with. And production. Could we copy this design? The engineering officers exchanged glances. Lieutenant Schmidt answered, Herr Oberst, we could copy individual systems, but the entire aircraft represents a design philosophy different from ours. The British accept weight penalties for strength and reliability. They use brute force where we use finesse. Their approach works because they have the engine power to make it work. Our Daimler-Benz and BMW engines couldn't power something this heavy effectively. Miller's report to Luftwaffe headquarters was diplomatic, but clear. The British Beaufighter represented a level of capability Germany couldn't match with existing designs. Attempting to copy it would require retooling factories and developing new engines, neither of which was feasible in 1943. The response from headquarters was predictable. The report was filed and essentially ignored. Germany would continue producing Messerschmitt 110s despite their known deficiencies. The Beaufighter's lessons wouldn't be applied to German aircraft design. But among the pilots who flew it, the captured Beaufighter became legendary. When Hauptmann Wolfgang Schellmann, a night fighter ace with 32 victories, was allowed to fly it in June, he returned shaking his head in wonder. Now I understand why we're losing the night air war, he told colleagues. The British have better aircraft. It's that simple. Their pilots aren't better than ours. Their tactics aren't revolutionary. But their heavy fighters are superior machines. The Beaufighter is faster than our night fighters, more maneuverable, better armed, and equipped with better radar. How are we supposed to compete with that? The captured Beaufighter revealed something German aviation had been reluctant to accept. British aircraft design, often dismissed as crude and heavy-handed, was actually brilliantly practical. The British built aircraft for real combat conditions, not theoretical performance. They accepted weight penalties for redundancy and survivability. They prioritized reliability over maximum performance, and it worked. Consider the engine installation. German twin-engine fighters used liquid-cooled inline engines that were theoretically more efficient. But liquid cooling meant vulnerability. A single bullet through a coolant line meant engine failure. The Beaufighter's air-cooled radials could absorb tremendous battle damage and keep running. Test firings at Stavanger proved this dramatically. Engineers fired machine gun bursts directly into a running Hercules engine. Multiple cylinders were destroyed. The engine continued running on the remaining cylinders. You cannot kill this engine, observed the German mechanic conducting the test. It simply refuses to die. Or consider the weapons installation. German fighters typically mounted cannon in the wings, with the barrels angled slightly inward to create a convergence point. This meant the weapons were only maximally effective at one specific range. Miss that range and firepower decreased dramatically. The Beaufighter mounted all four cannon in the nose, firing parallel. They were effective at any range from point blank to 1,000 yards. The stability was another revelation. German night fighters required constant attention to fly on instruments. The Beaufighter could be trimmed for straight and level flight and would maintain altitude and heading indefinitely. This freed the pilot to concentrate on radar operation and target tracking. In combat, this stability made an enormous difference. Major Faber conducted a remarkable experiment in July. He flew the Beaufighter at night using only the radar and instruments, never looking outside. Following radar contacts, he located and tracked a German bomber that was cooperating in the exercise. He maintained perfect position behind the bomber for 10 minutes, demonstrating how easily a British pilot could do the same to German bombers over Britain. With this aircraft and this radar, he reported, British night fighters can find our bombers in complete darkness, position themselves perfectly, and destroy them with a single burst. Our bomber crews never see their killer, they simply explode. Now I understand the reports from bomber crews about invisible attackers. The performance data continued to impress. The Beaufighter's range was particularly notable. With standard internal fuel, it could fly 1,500 miles. With external tanks, range extended to over 2,000 miles. German twin-engine fighters had half that range. This meant Beaufighters could escort bombers deep into occupied territory, hunt submarines far out to sea, and conduct long-range intruder missions over Germany itself. The fuel efficiency seemed impossible to German engineers. The Bristol Hercules engines produced 1,700 horsepower while consuming less fuel than comparable German engines. The British had developed superior supercharging that maintained power at altitude without excessive fuel consumption. German engines lost power rapidly above 20,000 feet and guzzled fuel at high power settings. In August 1943, Reichsmarschall Hermann Göring visited Rechlin and demanded to see the captured British aircraft everyone was talking about. Hauptmann Goetz gave him a tour of the Beaufighter, explaining its systems and capabilities. Göring was dismissive at first. "It's crude. Look at those thick wings. That blunt nose. British engineering always looks like blacksmith. Work." "Herr Reichsmarschall," Goetz replied carefully, "British engineering prioritizes function over aesthetics. This aircraft is crude in appearance but sophisticated in execution. Every system works flawlessly. Nothing breaks. Everything is repairable in field conditions. It's exactly what a combat aircraft should be. Can it match our fighters?" In combat, Herr Reichsmarschall, this aircraft would defeat a Messerschmitt 110 in most situations. It's faster at low altitude, more maneuverable, better armed, and more survivable. The British have built a heavy fighter that handles like a light fighter but hits like a bomber. Göring's expression darkened. He didn't like hearing that British aircraft were superior, but he was experienced enough to recognize truth when he heard it. He walked around the Beaufighter again, studying it more carefully now. What would it take to build something comparable? Oberst Miller answered, "New engines with at least 1,500 horsepower each, complete redesign of our heavy fighter concept, better radar systems, stronger airframes, increased production of cannons, possibly 3 years of development. And even then, we might not match British reliability." Göring was silent for a long moment. Then he said quietly, "We don't have 3 years." He left without flying the aircraft. His report to Hitler acknowledged British technical superiority in heavy fighters, but claimed German innovation would eventually produce superior designs. No such designs ever materialized. The captured Beaufighter continued flying at Stavanger through autumn 1943. German pilots from operational units were brought in for evaluation flights, giving them experience against the aircraft they faced in combat. The consensus was universal. The Beaufighter was the best twin-engine fighter anyone had flown. Lieutenant Ernst Schneider, a Messerschmitt 110 pilot with 14 kills, flew it in September and filed a brutally honest report. "Our aircraft is obsolete compared to this British design. Every advantage we thought we had was an illusion. The Beaufighter is faster below 15,000 feet. It turns better at all speeds. It's more stable as a gun platform. It carries more ammunition. It has better radar. It can absorb more damage. And British pilots have been flying these for 2 years, while we're still making do with updated designs from 1938. The psychological impact on German aircrew who flew the Beaufighter was profound. They returned to their units knowing they were flying inferior aircraft. They knew every combat mission pitted them against British fighters that were simply better. This knowledge eroded confidence and morale in ways that were difficult to quantify but impossible to ignore. Some pilots requested transfers rather than continue flying obsolete aircraft against Beaufighters. Others simply became more cautious, avoiding combat when possible. The aggressive spirit that had characterized German fighter operations early in the war was fading, replaced by a defensive mentality born of flying inferior equipment. By October 1943, the captured Beaufighter had logged over 200 flight hours in German hands. It had been flown by 43 different pilots. Every single flight report praised the aircraft. Not one pilot identified a significant weakness. The maintenance records told their own story. Despite intensive flying in the harsh Norwegian environment, the Beaufighter required minimal maintenance. The engines ran smoothly hour after hour. The systems functioned flawlessly. Nothing broke. German mechanics accustomed to constant repairs on Luftwaffe aircraft were amazed at British reliability. "We service this aircraft once a week," reported Feldwebel Klaus Becker, the crew chief. "Our Messerschmitts require daily maintenance. The British have built something that just works. Every time. Without fail. This is what German engineering should aspire to." In November, tragedy struck. During a demonstration flight for visiting officers, the Beaufighter was caught in unexpected severe weather. The pilot, Major Faber, attempted to return to base but crashed in the mountains 20 miles from Stavanger. Both Faber and his observer were killed. The aircraft was destroyed. The loss was felt deeply by everyone who had flown it. Hauptmann Gutz wrote in his diary that night, "We lost not just an aircraft today, but a teacher. That Beaufighter taught us more about fighter design than any German aircraft could. It showed us what's possible when engineering is driven by operational experience rather than theoretical performance. The British built something approaching perfection, and we destroyed it through carelessness. Perhaps that's fitting. We're destroying our chances in this war the same way." The official report on the crash concluded pilot error contributed to the accident, but weather was the primary factor. The real tragedy was that all the data collected from 200 hours of testing was compiled in reports that were largely ignored by German aircraft manufacturers and the Luftwaffe High Command. After the war, captured German documents revealed the full extent of British technical superiority that the Beaufighter testing had exposed. RAF Coastal Command. Beaufighters had sunk 263 German ships totaling 400,000 tons. They'd destroyed hundreds of German submarines. Beaufighter night fighters had shot down over 600 German aircraft. The Whispering Death had lived up to its fearsome reputation. In 1948, at a reunion of German test pilots in Hamburg, the captured Beaufighter came up in conversation. Hauptmann Gutz, now a civilian aeronautical engineer, spoke candidly about the experience. "Flying that British aircraft was humbling," he admitted. "We'd spent years believing German aviation was superior. Then we flew something built by British engineers we'd dismissed as unsophisticated. It was better than anything we had. Not marginally better, significantly better in almost every respect. The British didn't beat us through better tactics or braver pilots. They beat us by building better aircraft." The Beaufighter proved that. It was faster, stronger, more reliable, better armed, and more survivable than comparable German fighters. Those aren't opinions. Those are measurements we took, data we recorded. Wolfgang Schellmann, the night fighter ace, added his perspective. "Every British bomber we shot down in 1941 and 42 was a victory. By 1943 and 44, we were losing. The British had learned from their losses and built better aircraft. We kept building the same designs with minor improvements. The Beaufighter represented their learning process made manifest. We never had an equivalent learning process." The Bristol Beaufighter remained in RAF service until 1960, long after most World War II aircraft had been scrapped. The design was so fundamentally sound that it adapted to jet-age operations with minimal modifications. Over 5,700 were built in multiple variants. They served with 10 different air forces. Australian, Canadian, and South African squadrons used them extensively in the Pacific, where they proved equally effective against Japanese forces. The technical analysis conducted at Stavanger was eventually published in 1953 after documents were declassified. British engineers were surprised to learn how highly German test pilots had regarded their aircraft. Roy Fedden, designer of the Hercules engine, commented, "We always knew the Beaufighter was good. Having German experts confirm it was satisfying. They were excellent engineers. If they said we'd built something right, we probably had." Leslie Fries, the Bristol aerodynamicist who designed the wing, noted, "The Germans were obsessed with theoretical efficiency. We were obsessed with practical effectiveness. The Beaufighter worked because we designed it around what pilots told us they needed, not what our calculations suggested was optimal." Sometimes engineering is about listening to users rather than theories. The story of the captured Beaufighter reveals a broader truth about wartime aviation. Germany entered World War II with superior aircraft based on 1930s thinking. Britain entered with obsolete designs but rapidly developed aircraft based on combat experience. By 1943, British aircraft often exceeded German equivalents because British design incorporated hard-won lessons from actual warfare. The Beaufighter embodied those lessons. It was strong because combat aircraft take battle damage. It was stable because pilots need to aim precisely under stress. It was reliable because aircraft that break don't complete missions. It had redundant systems because single points of failure kill crews. It prioritized survivability over maximum performance because bringing crews home matters more than theoretical speed records. German aviation never fully embraced this philosophy. Luftwaffe aircraft remained optimized for peacetime performance metrics rather than combat survival. They were faster on paper, but less reliable in service. They were lighter, but less survivable. They achieved theoretical efficiency at the cost of practical effectiveness. The German pilots who flew the captured Beaufighter understood this distinction immediately. They recognized that British engineers had created something special, something that worked perfectly for its intended role. Their reports praised not just the aircraft's performance, but its thoughtfulness of design. Every system showed evidence of intelligent engineering applied to real problems. Hauptmann Gutz's final report on the Beaufighter, submitted before the aircraft was lost, concluded with words that were almost poetic. This British aircraft represents aviation engineering at its finest. It is not the fastest fighter, nor the most nimble, nor the most powerful, but it is the most complete. Everything about it works together harmoniously. Flying it feels natural, almost effortless. The Germans call this Fingerspitzengefühl, fingertip feeling. The British have achieved it perfectly. This aircraft is an extension of the pilot's will. It does what you want, when you want, without struggle or uncertainty. That is the definition of a perfect flying machine. In post-war interviews, several German pilots were asked to name the best aircraft they'd flown during the war. More than a dozen named the captured Beaufighter, not German designs, not even the celebrated fighters they'd achieved victories in. The British heavy fighter they'd flown for a few precious hours at Stavanger. Ernst Schneider, the Messerschmitt 110 pilot, put it simply in a 1962 interview. "I shot down 14 Allied aircraft flying German fighters, but if I'd had a choice, I would have flown a Beaufighter. It was just better. Better than anything we had. Better than anything I ever flew before or since. The British got it right. We didn't. That's why they won." The lessons of the captured Beaufighter extended beyond aviation. German engineers after the war studied the reports from Stavanger and recognized a pattern. British engineering, whether in radar, in engines, in aircraft design, consistently prioritized reliability and effectiveness over theoretical perfection. German engineering sought optimal solutions to defined problems. British engineering sought good enough solutions to real problems. In aviation, good enough solutions that work every time beat perfect solutions that work sometimes. The Bristol Beaufighter proved that with every flight at Stavanger, German pilots climbed into a British heavy fighter expecting to find flaws to exploit in combat. Instead, they found an aircraft that did everything well, nothing poorly, and inspired confidence from the moment the engine started. They found, to their surprise and dismay, something approaching flying perfection. 70 years later, surviving flight reports from Stavanger remain in German aviation archives. Researchers studying them are struck by the consistency of the praise, the professional admiration in every assessment, the honest acknowledgement that the enemy had built something better. These weren't propaganda documents. They were technical evaluations by experienced professionals. Their conclusions were unanimous. The British Beaufighter was the finest twin-engine fighter of its era. German pilots who flew it admitted this freely in reports that their superiors didn't want to hear. The aircraft they'd been taught to despise was superior to their own fighters. The nation they'd been told was decadent and weak was producing better weapons. That captured Beaufighter sat on a Norwegian airfield for 8 months, flew 200 hours, taught 43 German pilots about British excellence, and crashed into a mountain in November 1943. But its legacy endured in the memories of those who flew it. They carried that knowledge through the rest of the war. Every combat mission against Coastal Command Beaufighters, every encounter with RAF night fighters, every report of ships sunk or bombers destroyed. They knew the aircraft doing this damage. They'd flown it themselves. They understood its capabilities intimately, and they knew they were fighting an enemy that had built something they couldn't match. The morning that Hauptmann Gutz first climbed into that captured Beaufighter, he'd expected to find weaknesses to exploit. He'd found instead a revelation. British engineers working in factories being bombed by the Luftwaffe had created a heavy fighter that was simply better than anything Germany produced. Better in ways that mattered in combat. Better in ways that kept crews alive. Better in ways that won wars. Flying it felt like perfection because it was as close to perfect as 1940s technology allowed. Everything worked. Everything made sense. Everything felt right. That's what perfection feels like. Not theoretical performance charts, but practical effectiveness in the hands of actual pilots fighting actual battles. The Germans who flew it knew this truth. Their reports said so clearly. Their post-war testimonies confirmed it repeatedly. They'd touched perfection in the form of a blunt-nosed British heavy fighter, and they'd never forgotten how it felt. That captured Beaufighter told a story the Luftwaffe didn't want to hear. The British weren't crude engineers who succeeded through luck and numbers. They were brilliant practical designers who built exactly what was needed for the job. Nothing more, nothing less. Just enough speed, just enough maneuverability, more than enough firepower, exceptional reliability, total effectiveness. Hauptmann Götz had been right. That March morning, when he landed after his first flight, that aircraft is better than anything we have. The German pilots who flew it admitted this freely. The enemy had built flying perfection, and Germany had nothing that could match it.